Alright, in this question that talks about where to find the stationary point on each of the following curves, and the curves are here. So we know at stationary point the value of dy by dx is equals to 0, because at that point the curve is at rest. So let's go ahead and differentiate each of these functions, and we get the derivative of each one of them, and we equate it to 0 to get the value for y, since a point has two coordinates, x and y. So x squared plus 5y squared equals 20x. Then we differentiate each of these sides with respect to x. So 5y squared plus x squared will be multiplied by d dx from the left hand side, and the right hand side also we have 20x being multiplied by this quantity d dx. We can distribute the left hand side d dx of x squared plus d dx of 5y squared equals, now we can differentiate this directly, and the derivative of 20x is simply 20. Now this is also a direct simple derivative, so we have here 2x. We will differentiate 5y squared with respect to y and maintain dy by dx. So this goes to 10y, and then dy by dx equals 20. So we isolate dy by dx by taking 2x to the right hand side and dividing both sides by 10. Therefore, our dy with respect to x would be 20 minus 2x all over 10y. And we notice there's some common factor here, that is 2. We can reduce this further and have dy by dx as 2 multiplies 10 into minus x. So that if you open up by 2, you get here 20 and you get 2x. Then we have 10y, and you can reduce this by 2. 1 and 5 will be the denominator. So let's move on and write the remaining term here. dy by dx equals 10 minus x all over 5y. So this is the derivative function. And after obtaining this derivative function, we are requested to get the stationary point. So at stationary point, dy by dx is 0. So this quantity will vanish into 0 and we solve that equation. Now let's switch to the next part of the board. So 10 minus x over 5y equals dy by dx, and we know dy by dx at stationary point is 0. So we have 10 minus x over 5y, and we can multiply both sides of this equation by the denominator here, 5y. So we notice that this 5y will cancel and will be left with, from the left hand side, 10 minus x equals to 0. Solving for x, we'll have 10 equals x. Therefore, the value for x at this point is 10. Now, for us to get the point, we need y value also. And where do we get y? From our expression, which was the curve itself. So, x squared plus 5y squared equals 20x. Whenever we get x, we plug in 10. So you have here 10, and this 10 squared plus 5y squared equals to 20 times also 10. So this quantity goes to 100 plus 5y squared equals to 200. Collecting like term, 5y squared equals to 200 minus 100. So 5y squared should give us 100. Dividing both sides by 5, our y squared is 20. Getting roots on both sides, we'll have positive or negative root of 20. So therefore, y equals to positive or negative. This is 2 into 5. Then we can derive our point. So turning point here is having coordinate of x, and our x is 10. And then coordinate of y is positive or negative 2 root 5, and that is the solution to part A. Now let's move to part B also in the next board. So in part B of this question, we can do the same, differentiating each side with respect to x. So let's just distribute directly, and we have here the second term is 2y square with respect to x. The third term, we have dx of negative 4x. Somebody can write here negative, then dx of positive 4x is the same way. So we can go to the next one, dx of 7y, and then dx of 9 equals to dx of 0. So we can differentiate this, we obtain 2x. Now here, implicit differentiation, we have 4y, then dy by dx. So here is the normal differentiation, we have here negative 4, and here also implicit. Using chain rule, we have 7 dy by dx, and then the derivative of constant is 0, and also derivative of 0 is likewise 0. Collecting these terms together with the derivative function together, we can take their coefficients, 4y plus 7, and then multiplied by dy by dx. So the remaining terms, we take them to the other side, and we have 4 minus 2x. So we can divide both sides by the coefficient of dy by dx. We obtain, we can say 2 into 2 minus x all over 4y plus 7. That is the derivative. And then turning point again, dy by dx, or at stationary point, is equals to 0. So here we have 2 into 2 minus x over 4y plus 7 should be equals to 0. Meaning if you multiply both sides by this, by the denominator, it will just vanish into 0. So therefore, writing it up here, we'll have 2 into 2 minus x will be equals to 0. That is after multiplying by the denominator here. Now we simply have here, when you divide both sides by 2, getting here 2 minus x equals to 0, where our x is equals to 2. So let's again get the value for y. Our original function, which was x squared plus 2y squared minus 4x plus 7y plus 9 equals to 0. Wherever we get x, we plug in 2. So 2 squared plus 2y squared minus 4 times 2 plus 7y plus 9 equals to 0. So this one simplifies to 4 plus 2y squared. This one goes to 8 plus 7y plus 9 equals to 0. We can start with the leading term here, 2y squared, then the next one here is plus 7y, and we sum this together. This one simplifies to positive 1, and positive 1 to this 5 is the result of adding 1 to 4, making 5. So we have 0, and here we have a quadratic equation to solve. Now the best method here could be formula. So under this we'll state the value of a as 2, and then the value of b 7, and the value of c is 5. So having done that, we put our formula. The value of y will be obtained by negative b, positive or negative b squared, and the root for ac, and the whole thing is divided by 2a. So we can make our substitution such that y value can be obtained by b is going to be negative 7 plus or minus 1 square 7, and we subtract away 4 times value of a, which is 2, times c, which is 5, and then we divide the whole thing by 2 times the value of a, which is also 2. So we continue simplifying. Have negative 7 plus or minus inside this bracket 49 minus 8 times 5, that is 40. And then we get its root for negative 7 plus or minus, in the bracket there we are left with 9 over 4 gives us y. So as we simplify this, we'll have negative 7 plus or minus 3 over 4. So either y is given by the upper sign 7 plus 3 divided by 4, which simplifies to negative 4 by 4, and y is negative 1, or at this point you take the lower sign here, so y is given by negative 7 minus 3 over 4, and this one sums to negative 10 by 4. We can drop it up denominator and numerator by 2, so we obtain negative 5 over 2. Therefore, the points that we'll obtain here will be x value was 2. So we have 2 points. The first one could be 2, negative 1. And the second one could be also 2, negative 5/2. So these are the 2 points, the stationary points that lies on this curve. So up to this time, thank you for watching. But before we hop out of this video, let's take a look at checkpoint, and I'll give you the answer as well. So in this checkpoint, it says find the stationary point of the curve x cubed plus 3y cubed equals to 81. And here's the answer. So please go ahead and work out this number following the same steps like what we have done in question A and B, such that you will obtain something similar like what we have here. Thank you for watching. Please remember to give this video a thumbs up, subscribe to the channel to get more interesting videos just like this one here. See you in the next one. Goodbye.